Great, okay. So yeah, good morning, good afternoon. I was kind of surprised when I found out what time I was speaking, like about 12:30, 12:20 or something like that. And I remembered the first time I came to Spain and I was like working with a team and they said, hey Mike, do you want to go to dinner tonight? And I said, yeah, that's great. But I have to drop off my stuff at the hotel. And I said, why don't we just sort of like, we'll meet at 6 o'clock. And they said, Michael, that's not dinner, that's lunch. You know, and I'm kind of like, okay, so things are shifted here a little bit and that's okay. Kind of love it. So I want to go and talk to you about something that kind of came up in the context of some work I was doing to basically help some people understand systems. And I'm sure this is something that you've dealt with all the time. When we have like attrition in organizations and people go away and new people come on, and you have to basically onboard people into systems, often there's this thing of like, how quickly can they learn what's going on in the system? How can they learn about the structure within the organization, the way that all the components are organized? Where do you go to and actually fix something or do something within the system? And invariably, the thing about this is that you've got these two things you have to go and deal with. And it's really the structure of the processes in the organization itself, and then actually the structure of the code in the system. And hopefully they're somewhat aligned in some way, right? And we basically have things we can kind of fall back on in some sense. There's Conway's Law, right? Everybody's kind of familiar with Conway's Law, I bet, right? So very old idea put out by Mel Conway in the 1970s, or actually the late 1960s. He made the observation that essentially in any system that's designed, it's kind of like the structure of the teams that produce the system ends up going and mirroring itself in the design of the system. So if you have like 3 teams, chances are you're going to have like 3 components, for instance. And it was kind of funny because it took a while for him to go and actually get this published because he didn't have any like data to go and actually show this. It's really just something he'd seen in a number of different organizations he'd worked in, right? Now, it's kind of funny about this because sometimes people look at Conway's Law as being like a little bit of a mystery in a way. It's like, wow, why is it that the structure of the organization mirrors the structure of the architecture and vice versa? And in his original paper, he basically gave a bit of an explanation. He basically pointed out that it's like if there's more cost of communication between teams than there is within a team, then it's kind of like the structure of communication you're gonna start to work on your own stuff rather than going coordinating with somebody over and over again. So you're gonna have natural modularity that results from the structure of the organization. That's just kind of mirrored in things. But I think one of the things that's kind of fascinating about Conway's Law, though, is that when you really think about it at a very abstract level, it shouldn't be any kind of a mystery at all, right? Let's try to see if I can explain this because it feels kind of weird to explain. But like imagine that you're basically working in a building with a bunch of people, like before we did a lot of remote work and stuff, right? And it's like the janitorial staff comes in the middle of the night to go and clean things, and they kind of notice that some rooms have more trash in them than others do, right? And you can basically say, well, there's more trash in certain rooms because people are working in those rooms as opposed to the other rooms and stuff like this, right? So the fact of the matter is that essentially it's kind of like, when we structure teams, the reason we're structuring those teams is to get particular bits of work done. And we would be surprised if there was no physical evidence of their communication that was like adrift in the world, like the trash that you leave in a conference room, for instance. Because it is all one big system, right? We like to go and actually have this view where we say, well, here's the process view of the system. Here's the people view of the system. Here's the technology view of the system. But they're all different views of the same system in a way. And we can't really go and pull the people out of the system and expect to go and actually sort of like even find that in actuality someplace. You'll never see people organizing themselves in the way that they organize themselves to do software in any other context because we are intermingled in the system with the software that we have, right? So it's kind of a struggle then when you basically realize this to go and sort of like see people do some terrible things, okay, that I've seen happen across the years in the industry. I remember going to Munich, Germany once and basically saying, okay, well, can you please explain the system to me because I was going to do some consulting work with them. And they said, we know nothing about it. It basically was dropped on us last week. And so essentially there was an acquisition, one company to another. They were given this entire code base and they had to learn it from scratch to go and figure out what's going on with things. How well does that work? It doesn't really work very well at all, right? And it's because the team and the code grew together in a way. And if you pull one piece of it away, you've lost more than half you've lost a lot of what the system happens to be. So, for me, when I basically confront this situation in my work context these days, I always think about, this old book that I read a long time ago called Object-Oriented Reengineering Patterns. And it's not really so much about object orientation, but it's an early book that really kind of confronts this problem of when you basically need to understand a system, this is what you need to do, right? And it has lots and lots of very interesting advice. And, right now I'm actually working with several people on this other thing, which may turn into a book, which is really called Patterns of System Renewal, which is kind of like in the same space. What does it take to go and take a system that you know very little about and make it workable so that basically you can sort of like, it's capable of supporting the work well by the team that you basically assemble around it. So yeah, there's this problem of like, how do you actually start to go and understand a system that you've never seen before? And then beyond that, it's kind of like, once you've kind of understood the system, can you do things that basically help you sort of like give it some guardrails as you move forward and do things? So the idea is this: you need to understand the system well enough to be able to determine the next steps. So what's this like for you when you need to go and actually sort of understand a system, right? I worked with somebody a long time ago who was terribly impressive to me. We would go to client sites, and then people would start to explain the system to him. And then it's kind of like he would start to fill in the gaps and start to tell them about their system, even though he'd never seen it before. And it came from having a lot of deep experience and exposure to many, many different systems. You start to develop the intuition to go and fill in the gaps, right? And I discovered as well that there's this key skill, which is part of this, which is to be able to listen to a lot of unrelated information and live in that ambiguity for a while, and then let things crystallize and basically become the things that you use, kind of like coat hangers in a way, to kind of like understand. It's like, oh, I've seen this particular thing. It's like, now I can kind of like associate it with this thing. And I can associate it with this thing. And then sometimes you have to reshuffle the things on the coat hangers in a sense as you're going and building your understanding of the system. But there is this thing of going and listening to a lot of detail and trying to go and gather enough to go and start to get a crystallized understanding of what the system does. And so this is a key aspect of that as well. But it's funny, I want to go and take a step back about this. So when we're doing this work of going and trying to understand the system, what we're really doing is we're constructing a model, even if it's only just in our heads, right? Constructing a model. Well, what does that look like in architecture for us, right? If we look back over the history of architecture, we'll find various things like Philippe Christian's 4+1 view of architecture, right? A rather early thing from the 1990s where basically he sort of said there's these different views of architecture. You can use these to go and understand and document the architecture you have. And these are not, they may not be exhaustive for going and understanding an architecture, but they're enough to go and start to get a handle on exactly what it is that you're having to deal with. And it's kind of fascinating about this. It's like, we are in this world of services and microservices now and everything like that. But a lot of this still kind of stands up in a way. A thing I would point out about this to you that I think is kind of interesting is that for all these different views that you can have of a system, a lot of them basically have to do with things, right? When you have the conceptual logical view, you're going to have diagrams that basically show classes and stuff like that. And classes are things in the system. And in much the same way, it's like if you have components in your system, components are things in the system. Database tables are things in the system, right? There's the physical view that we have in the lower right-hand side here, things in the system yet again, and services and everything else that we can basically sort of deal with. So in a way, it's kind of funny because it's really kind of like, I don't know, we have a very thing-focused thing, or we have a particular modularization that we came up with when we were designing the system, and we basically sort of like hold that in reverence to some degree, the modularization that we have basically been given in the system. Let's move forward a little bit. So there's the C4, view of architecture from Simon Brown. And this one is particularly thing-focused in a way. It's kind of like he has 4 different views: context, containers, components, code. And it's all about the bins that you put things in, right? And understanding what those things happen to be. So yeah, I loved Mark Richards' talk this morning about modularity and granularity, because I'm going to kind of borrow things from it a little bit. But the thing that's interesting to me about this is that it's kind of like the modularity. I think modularity in many cases, it gives you optionality in design, and that's great. It also tells you where to look for things, which is like a key thing that you really need when you're going and actually figuring out where to find something, and actually, better still, figuring out where to put something in the context of design. So we use modularity as like a navigation aid across systems as well. So yeah, this view, it's kind of like it's all things, it's all kind of containers, and it's really kind of like entities all the way down. Okay, so Katerina basically gave a wonderful, overly long introduction to me a little bit earlier, but I'm just going to go and say again, hey, it's kind of like, allow me to introduce myself. I'm Michael Feathers. I work in LEC. What is LEC? Well, L is legacy and C is code, right? I spend a lot of time working in legacy code. The E is existing, right? And I think that for the most part, most of us here, we work in existing systems, and they have like to some degree, some kind of a legacy nature to them. And this is not atypical. The thing is that we build systems, and then there's entropy that occurs over time, and you basically get into this state where it's kind of like sometimes things aren't quite in the place that you expect them to be. They aren't in the right place for your current understanding of the system, which is what Ward Cunningham basically referred to as technical debt. When your current understanding of the system does not match the system that you see, in a way. So it's kind of funny with this. If you're going into sort of like taking seriously the fact that things can drift over time in a system, what's a good way of going and seeing the system? And if we find a good way of seeing the system, can we find it in a way, can we find a way of seeing the system which goes and helps us sort of maintain its integrity over time? And that's what I'm kind of getting into with this. Another lead-in I'll use to go and sort of talk about this a bit. A very interesting experience I had early on in my career was basically learning this practice that I use quite often when I'm trying to understand systems. And I call it telling the story of the system. And this is really kind of an interesting thing. It's almost like, progressive disclosure from UI design. It's kind of like you do something in the UI and you don't show everything, but then basically as people need things, then they kind of appear within the user interface for people to go and understand the next task to do and various different things like that. We can do the same thing when we're explaining systems to people, right? So here's a very small microsystem. This is like a very early version of JUnit, right, the testing framework. And you can see the various classes that are here, and you can see the methods and stuff along those lines. If I was to try to explain this system to somebody, what it would do is I would go and start, not from here, I would start from something very, very basic. And this is something I got from Kent Beck way back in the day. He basically said in an offhand comment one day, if you can't explain your system with just 4 objects, you don't have an architecture, right? And it's kind of weird because it sounds like a very cryptic statement, but it also has a ring of truth to it. It's like when you actually look at explaining a system and trying to understand it, you should be able to go and sort of like allow people to focus in on the most important thing and then expand their understanding over time to help them see what's going on with things. And if your architecture is good, people can see those pieces. They may not need somebody to go and explain them to them. So to give you an example of this, for this little JUnit system, a way of explaining this is to go and say, okay, well, rather than going and giving you the 12 classes that make up this system, I'll start with what I think is most important. And the most important relationship here is that when you in the JUnit system have a test case, there's an associated test result that it talks to. So you can execute a test case, and when you execute the test case, it reports its results to the test result. And it either adds an error or a failure for that particular test, failure or error, that kind of thing. And I think that's the core of the system. And you can explain the relation between those 2 objects, and everything else that we would talk about is just kind of like gloss in a way. Sure, you have a test suite which goes and holds onto a collection of test cases. And beyond that, there's a test listener that's basically test results talked to. But that core relationship between the test and the test result is the most important thing that gives you a coat hanger for your understanding of what the system happens to be. So yeah, the insight from this that I get is that when you're telling the story of the system, it's kind of like the pieces themselves can be kind of arbitrary in a way. And the other thing is it's kind of like, you're basically telling a story about a couple of objects interacting. They may not be actual objects in the system. They may not be actual services, but they're almost conceptual placeholders you use to tell a story about what the system actually does. And when you're doing this, sometimes you'll find misalignment between the story that you're telling and what you know to be truth about what's going on in the system. And you should pay attention to that feeling when it's kind of like, oh, things feels like I'm lying when I talk about this because there's all these other things going on too. But that really offers you an opportunity to go and actually say, well, gee, couldn't it just be that way? Couldn't it be the simpler system, and why can't it be the simpler system? So this kind of thing helps us basically find alignment within systems. Okay, so now we're going to launch into the real meat of this. Some of you may have heard of responsibility-driven development, like from early object-oriented days, CRC cards. This is from a long, long time ago. But back in the early days when people were first trying to explain object orientation to people, one of the props that people would use is they take index cards, and for every class in the system, you write down the class name, the collaborators of the class, and the responsibilities of the class. And this was like a great way for people to communicate about a design and interaction of things. And I think, services today really are filling in the role that a lot of the early objects were within object orientation in the early days. We're dealing with this at a higher scale and doing it in a nice way, but a lot of these design principles still apply. The thing about this, though, is that this point of view kind of originated with Rebecca Wurzbach, and she's, a wonderful person, and talked to her about this a bit. And, I always loved her view that responsibilities are primary in systems. What does the thing do for you, right? And if you think about what those things happen to be, then you're able to go and sort of like, organize your thoughts about the system in a nice way. So I think we can look at responsibilities as units of cohesion. And all the conversations we have about coupling and cohesion in systems, we can use responsibilities as a basis for going and understanding cohesion to some degree. And the thing to think about with this is that for just about any system, you can find cohesion at all levels. You can find some of the ugliest code and take a look at it, and sometimes just almost like arbitrarily go ahead and sort of like try to go and say, hey, these pieces together, what does this mean? What is the constellation of these several statements doing for me? And sometimes you'll find something that you can name well and basically say, I could extract this if I wanted to. And other times you can't necessarily find a thing that you would extract well. But being able to see these interacting pieces that are close to each other, hopefully they're close to each other, as particular responsibilities that you can go and sort of like see independently of the code or the system diagrams is a very key skill for anybody involved in software development. So you can see this at the function level. You can see this at the class level where you see clusters of things that look like they're about the same thing. It's important for us to go and recognize that quite often these things are axes for change, right? If you have something which is, here is all the code about this particular responsibility, if you have an abstraction around this, then you can basically substitute abstractions to go and do things in a slightly different way using polymorphism and stuff along those lines. So there's this way in which the cohesion that we have in systems quite often hides behind the decomposition that we have, right? We often have a level of cohesion or groupings of cohesion that are at a lower level than the pieces that we've actually constructed in the system. And they aren't often aligned all that well. And this all kind of like applies at the service level as well, right? Services are basically units of decomposition, but they may have a good cohesion, score, for instance. But basically there are pieces inside them which are cohesive as well. So let's dig into cohesion now a little bit. Okay, I mean, there are many different kinds of cohesion. If you look through the literature in the industry, you'll find a lot written about cohesion. Not quite as much recently. I think we deal with coupling way more than cohesion these days, which is kind of unfortunate. But the thing is when you look at the earlier literature about cohesion, one of the things that you arrive at is that essentially the last one that was listed here, functional, tends to be the one that people tend to like much more. It's basically going and saying that this is centered around a particular task, and this is the thing plus the things that are needed to go and actually perform this particular task in the world. And that sounds an awful lot like what responsibility is, doesn't it? I would carry something a little bit further from that. When you look at this definition, there's something which feels like an unnamed concept in the literature around this. And I think it's the concept of a subsidiary in a way. So it's kind of like you have a thing which has a responsibility. It could be a service. But there's all the supporting things that you have inside of it, and those could basically be seen as having their own responsibilities. But those are subordinate responsibilities to the main responsibility of the thing that you're actually going in and creating, right? So sometimes these subordinate responsibilities, they can live on their own in other services, or they can basically live inside that particular service, for instance, as subpieces or things that you do in service of doing the main service thing that needs to be done. So we have this what, how boundary that we basically confront all the time in systems development, right? We have the responsibility of the entire system. We have the responsibility of the services, responsibility of the classes and stuff like that. But there's always like a further decomposition layer where we basically go ahead and decompose the responsibility into entities, for instance. So let's look at this here. I'm speaking abstractly, so I'm calling these things entities, these boxes. They could be services, they could be components in a monolith, They could be classes, but in all these cases, regardless of what level we're approaching a system, you have entities and you have responsibilities, and there's some kind of mapping between them, right? So if you look at this, it's like on the left-hand side here, we have entity 0, which has responsibility 0 and 1, entity 1, which has responsibility 2, entity 2, which has responsibilities 3, 4, 5, and 1, right? And this is the typical, patterning that happens in systems. It's very common to go and find an entity that has several responsibilities, and it may be that there's a primary responsibilities, and these are subsidiary responsibilities that are in service of that primary responsibility. Or it could be that these are things which tend to be used at roughly the same time, so there's temporal, cohesion there, for instance. The case that we love is the middle case here for E1, where you basically have a single responsibility, and basically any further decomposition of responsibility you have inside is pretty much opaque to you. You don't have to go and care about it too much. You basically see things in terms of the primary responsibility. E2 is where things get kind of weird here. So we have all these responsibilities, and they're distinct from the other ones except for, the very last one there. So responsibility 1 is shared, across component E0 and E2, right? What does that mean for us? How does that happen? Well, these could be in completely separate domains, and we don't mind a little bit of duplication of code, perhaps. Or it could be accidental in the sense that basically you have things in the same domain, but basically somebody put billing code over here, even though billing code kind of belongs over there, right? So you have this thing where it's kind of like, well, what do we do here? Should we actually pull this out into a separate entity? Yes, no, maybe, that kind of thing. But I think the important thing to recognize with this is that, these things all happen at levels across the entire system. And it's like you're sometimes not going to go and make the granularity decision, the decision to go to very high granularity for various different reasons, which like Mark outlined in this talk a little bit earlier, sometimes with scalability and fault tolerance and stuff like that. You don't want to go and, stretch things out all that much. But there is this sense in which we want to go and actually figure out what view of responsibility is primary in the system. So let me give you an example of this. Okay, this is in a fictitious domain, but based on a real system. Fictitious to protect the innocent, right? Protect the guilty? Sorry, anyway. This is kind of like a little workflow engine, and you can kind of imagine this as almost like, imagine you had something which is going to construct like Lego pieces, like Lego assemblies, of different, Lego pieces. And you're given a bunch of specs that basically come in, specs for different kinds of pieces. And they basically come in, and there's pre-processing that's involved in doing that. And there's basically some data analysis that's done to go and actually sort of like understand a bit more about what the pieces are. And then you basically start building models of assemblies of those particular pieces. And then you select particular ones that you're going to go and elaborate further. That's what select targets is. And then you basically create an assembly summary for each of the assemblies, for the assembly that you chose. And then you do work allocations for going and putting these pieces together. And you do further modeling, and then you create a report. Is this clear? It's a fictitious domain, so I can't go and ask that, very seriously. But the thing about it that's kind of interesting is that these names are not really matching exactly what's going on in the system. There's definitely been some drift between the names and like the description I just gave you of what's going on to some degree. So after kind of looking in the system and investigating and digging in and stuff like that, we kind of discovered that, these are the primary responsibilities of the system. Okay, you're going to make a report. That's what this entire thing does, is it creates a report for you. It reads the piece specs, okay, creates sub-assemblies, creates assembly diagrams, builds assemblies from sub-assemblies. And it doesn't do these things in this particular order, but when you look at it, you should be able to go and see these responsibilities manifest someplace within the architecture of the system. And sadly, here you don't quite. So what we can do is we can essentially map this out, right? We can go ahead and say, okay, let's go ahead and sort of like list all the responsibilities and then list the locations where the code for these things happens to reside within the system. So make report, it happens within this report component that's at the bottom, and part of that also happens within summary reporting. Reading the piece specs paradoxically happens in pre-processing. So that's not a great name for actually going and encompassing that particular responsibility. Calculating the sub-assemblies happens in data analysis and pre-processing. So why is some of that happening in pre-processing? We don't know. Create sub-assembly diagrams, that happens in work allocations and modeling. Build assemblies from the sub-assemblies happens in perspective and select targets. So it's kind of weird. We'd love to go and have the system where basically the responsibilities have been made a bit more manifest. And the interesting thing is, how do we actually get there, right? We could do a lot of refactoring. We could do a lot of different things. We could do a lot of renaming of things. And then we can kind of like try to put guidelines in the architecture where we say, you know, if you're basically going and reading the piece specs, it's going to go in this particular stage, and none of that should happen in another one of these stages, right? And so you have guidelines about what belongs where and what you're going to go and do with these various different things. So you can do that sort of thing, but I think the main thing about this, though, is trying to go and actually figure out what is the privileged view that you want to go and have of the system. And then, if you're thinking about the system in those terms all the time, hopefully you start to get alignment over time, right? What if we had a view of this architecture, which is really all about these responsibilities we identified, and we essentially use something like this as a map of the system? Here are the responsibilities. These are the locations where the responsibilities are manifest in the system. And we should be asking ourselves periodically, it's like, well, gee, why is this particular responsibility spread across these particular components? There might be a decent reason why we might want to go and do that sort of thing. It could be accidental and something we don't want to go and perpetuate over time. So we should be in a position to constantly have that conversation of like, well, what can we do to refactor and start to align these things to basically go and bring them more in, bring the system more in the view of this, the view of the system that we really would like the system to be, in a way. So that's the crux of what I'm kind of like getting at with this, is that we can basically go and find this particular way of going and looking at the system, bring things into alignment by speaking solely in terms of these responsibilities, and in some way considering them to be a little bit more real than the physical manifestation that we actually see of the system itself. We bias heavily towards the component and service structure of our systems currently, right? And in Mark Richards' talk this morning was interesting because he was getting into that thing of like, we have a notification service, and it's like, it's either going to be text or it's going to be email or it's going to be SMS, text, email, or what's the other one? Postal letter, of course, the wonderful one, right? And it's almost like leaky abstractions in a sense, that basically because we're making a distributed system and we have these things like fault tolerance and scalability, that we would break down these responsibilities into, we'd bring these to the service level in order to go and basically deal with this particular issues, which is a fair trade-off to make. But the view of like, well, hey, there's this thing, and it could be a grouping of services, which is about notification, and seeing that as like a key thing is kind of valuable for us, right? So how many responsibilities should we see the system in terms of, right? Well, it's an interesting question. It's kind of like there's this old advice from the 1950s. So you ever hear about the 7 plus or minus 2 rule for cognition in a way? It says that typically for a person, it's kind of like you can't really hold more than about 7 plus or minus 2 things in your working memory at once, right? That's just the way we're kind of built in a way. Sometimes you can have lots more in your working memory, sometimes less, it really depends. If you really need to memorize a lot of things, it pays to group things together into 7 plus or minus 2 chunks. And then you have like navigability. You can say, hey, I've got this one chunk and it's got a decomposition of another 7 things below it and stuff along those lines, right? So you start to go and actually see things in terms of those way. I think the interesting thing for us is that we can apply this responsibility view at a fractal level within systems and basically choose for anything that we basically care about to go and just sort of like say, let's not really move beyond 7 or so items. And in a way, when we're doing this, we're kind of imposing a shape on the system. Okay, we're kind of going and saying, regardless of how bad things have gotten, we want to see the system in this particular way. And if we see the system in this particular way, hopefully over time we're going to bring our system in alignment with our vision of what the system happens to be. So it's very much like, if you've ever heard about like, I think in business they use this term MECE every once in a while, M-E-C-E, which is mutually exclusive and completely exhaustive, right? When you separate things so they really are, the Venn diagrams have no intersection at all. The reality of the system might be that we have lots of overlapping responsibilities across different components and stuff like that, but ideally we'd like to flip things around and have a view where we have separation of these responsibilities and we basically can map to the locations that we have these particular things and then basically sort of like move them into alignment over time. I think to properly date this presentation, I put this picture in. This is like generated through like a DALL-E clone, kind of like, Stable Diffusion AI. I asked it to go and produce a picture for me of a cucumber and brine with a pickle in it, and it did this for me. Yay, right? Technology, right? But I created this picture to go and sort of like bring up this quote from Gerald Weinberg, and he was talking about consulting many years ago, and he basically pointed out that basically proximity in a system quite often goes and leads to merging of things in a way. And he was talking about this in terms of consulting, basically going and saying, like, if you're a consultant, your main benefit for an organization that you visit comes from the first couple of visits. And after a while, you start to soak up so much of the worldview of the people that you're working with that your utility is kind of reduced a bit because you're starting to see things from their point of view. If you are separate, you maintain a difference of point of view that allows you to see things that other people might not. This same principle really kind of aligns with what I'm talking about here. So it's kind of like when it's kind of like if we tend to become very attached to the componentization scheme that we tend to have in a system. If we can maintain some distance to some degree, then we're able to go and actually sort of like facilitate change within the system that way. It's kind of funny with this. I gave a bit of an example of what responsibilities are like in a bit of a workflow architecture, a pipeline architecture. But I think one of the things that kind of comes up when I talk to people about this a bit is that a lot of this really kind of depends upon the particular architecture you happen to be in. I borrowed some stuff from Neil Ford and Mark Richards' book. If you can punch me later for using your diagrams if you're offended at all, right? But one thing that's really kind of interesting about this is to notice the issue of architectural style. When you're looking at things at the macro level for a system, if you have particular architectural styles that are really technologically partitioned as opposed to domain partitioned, it's kind of weird to go and sort of say, hey, what are the responsibilities in that space, right? Imagine an old style layered architecture. It's kind of like, are the 7 responsibilities, maybe 4 of them are presentation layer, business layer, domain layer, and database layer. It's like, it doesn't seem like a proper unit for responsibility in a way, right? But more modern architectural styles, we tend to basically move more towards domain focus in service orientation and microservice orientation. And so you can usually find the domain at some level in your system that you would like to go and actually talk about. So you'll find domains in various like service-oriented architectures. You'll find them quite often in event processing architectures. Then you have like things with like enterprise service buses and stuff like that. Where you have technological partitioning, you have a choice though. Even though we move towards strongly domain-oriented architectures these days, for ones that sometimes you're working with an architecture where the architectural style dominates to some degree. And I see no problem really with, in those cases, going and seeing particular aspects of your architectural style as being the responsibilities themselves. And it's kind of like shoehorning in a way this worldview on this, but the entire thing, I think the crux of this, is getting down to 7 or so, at whatever scale you happen to be working in the system, and basically going and saying, okay, well, these are the 7 things to go and care about in this particular level. And you can see these particular things, and then you can basically use them as an index into the system. Okay, so this is like a old style index from a binder, and you can see that it's using numbers here. We would have real responsibilities. What is an index good for? Well, it's kind of funny. The table of contents in a book is an index, right? What does it help you do? It helps you navigate. It helps you see things separately. The index of a physical book, and they're less common in electronic books these days, again, gives you another view into the system you can use to go and find things. So we can basically go ahead and use these responsibilities as a way of navigating into a system, and that's kind of nice, but there's more to it that we can do. And so just to go and sort of back up into this a little bit, another thing that you can do is that you can basically go and have a quality view that's associated with your responsibility index. Okay, and this comes from an old idea that I had many years ago working with some teams and recognizing that one of the issues that comes up quite often in systems is that you have like discontinuity between the way that the business looks at the world and the way that developers look at the world, right? So business is quite often interested in features and functionality, and they want to know how long it takes to get things done. And there's all these concerns which are basically part and parcel of what we do as developers and architects to go and build out our systems. And then you quite often will have this endless conversation of like, well, it should take less time than that. And it's like, no, you don't understand. There's technical things going on in the system. And because of these particular things, we can't actually do that sort of thing. And that's where the entire metaphor of technical debt came from. The need to communicate with business from development about what is possible in the system given the state of the system. And so I started thinking about this, and I thought, what if there was some more transparency? And I put this idea out in a couple of conference talks, and a guy named Colin Brecht from Tesla tried this out. And what he came up with was this. He basically had like a component diagram of the system he was working on with his team, and they used colors to go and indicate the readiness for change of the different areas of the system, right? And so dark red is like, okay, things are really bad here, it's going to take a long time to change things. And orange is like so-so, and light yellow means it's relatively easy to go and change things. So imagine having this conversation with people that are, you're working with, and they say, well, we need these particular features, we need them and such, and you can say, oh, okay, well, that's cool. That particular feature, though, it touches this area of the system, this area of the system, and this area of the system. And you can see one of these is really, really red here, so it's probably going to take a little bit longer. And so you start to bring in the business and give them a view of the system that helps them see the things that you're having to deal with. And then when they see that, hopefully they can understand why some things take longer than other things take, right? So some organizations are doing this kind of thing. It's nice. It's a cool thing. The thing that's kind of funny is because I just presented the idea at a conference talk, he just kind of ran off and did this, and I looked at the diagram here, and the first thing I said to myself is, you don't need the lines at all, really. These are kind of like subject areas in the system, and you could basically do the same type of thing just by going and, having, a set of boxes and go and say, okay, well, feature comes in, okay, that's going to go and basically deal with price calculation, reconciliation, and inventory. And it's kind of like inventory is really in a bad state right now, so it's going to take a little bit longer to do things like this. The thing Colin pointed out when he was doing this was it's really kind of fascinating because even without talking about technical debt at all, you can start to approach it when you're doing this kind of thing with your, the people and product. It's kind of like they'll start to ask you, why is this area so red? Why is it getting in our way? Can you do something to fix that? And it's great to go and actually have business-motivated reasons to go and actually refactor things. It's kind of a fun thing to go and actually sort of see that happen without, direct conversation about technical debt at all. So yeah, the thing that I'm kind of like looking at now with this is that, if we do this sort of thing, it's kind of like we could basically use responsibilities as the basis for this rather than the current componentization scheme. Why would that be kind of interesting? Well, even if you have some code for a single responsibility that's kind of spread across different areas of the system, you probably want that to coalesce at some point. Or if that responsibility is kind of key, you want to go and basically have the same approach to going and working with that particular responsibility in the system. If you don't, things start to fall apart, right? So if we basically go and index using responsibilities, we have, a little bit of extra utility here. And other views as well are possible. So I've done this with people where we basically do business value views, where you're going and sort of like saying, these are the key responsibilities in the system. Let's go ahead and look at these things from, say, the Wordly map perspective, where you say this is a thing that might be something we might want to go and sort of like commodify. Here's something we might want to go and buy rather than build, things along those lines. And you can apply that to existing systems when you're looking at re-architecting them, for instance. Quality, it's the one I just basically outlined, having a quality view of the system based on responsibilities. This last one I think is the one that's most important. And that is the thing that I think we run into quite often as a problem in development organizations because we haven't considered the alternative. Quite often we tend to go and have like, we tend to have like one way of engaging with code and process in an organization because we're writing code and we should basically have certain standards like a certain amount of test coverage, for instance, and a certain commit process and all these different things. Not all areas of code are valuable relative to each other, right? Some are more valuable than others. Some areas of the system might have a much more lax change basis than other areas of the system. Some parts are so critical, you might want to have key reviewers going and look at the pull requests for these things, right? So what you can do is you can say, based on responsibility, I want to go and actually have rules of engagement that you would use for working in the system. You would go on and say, it's like, okay, well, this is really a very critical part of the system. We have these tests that need to go and run for this. There's a higher regimen of testing for this particular area. This area, not so much. Anybody can change it within the team. They can make a commit without even a pull request because we feel comfortable doing that particular thing. As well, in terms of rules of engagement, there might be particular long duration refactorings, large scale refactorings that you want to go and do over the period of several months and record them in the index in that space. It's kind of like the rules of engagement for this responsibility is if you were doing something here, you basically want to align with this refactoring or progress it. You want to basically go and start to go and say, okay, this is, I'll do a little piece to go and basically make this refactoring move forward, or at least not do anything which is going to basically impede that refactoring effort over time, right? So this is really kind of like a way of organizing information. Ideally, there would be tool support for this kind of thing, but it really comes down to this thing that I think is kind of key, is that, we bias towards the system that is there, and it would be great to go and have a map of the system which encompasses where we are and where we want to be, right? And the thing is, this isn't going to be our component diagram necessarily, okay? This is going to be something which we actually use to go and actually realign with the cohesion that we want in the system, the cohesion that basically makes it easy for us to go and navigate the system and understand the system. So that's pretty much what I've got. And yeah, thank you all very much for inviting me, and I guess I can open up for questions.
With the change index, red, yellow, green, how do you determine what is hard or easy to change? What metrics do you use?
What is hard or easy to change? I tend to go subjective with a lot of these things. I think when it gets down to effort, it really has to come down to based upon the experience of the team, right? If you don't really have a team and you're basically taking a code base you've never really seen before, you can look for complexity and things like this, like just run hypotheticals. Like if I had to do something like this, how much is involved in understanding the context and making the changes across the system? In terms of hard metrics, I don't really see too much in that space that I would basically substitute for the good judgment of somebody who's experienced. So, yeah.
Okay. And then you mentioned that maintaining the distance could benefit a consultant to have a different viewpoint than the client's organization. What do you mean by distance? How to particularly achieve it?
Oh, okay. Well, typically that's like worldview. And I guess I was using that anecdote from Gerald Weinberg to talk about that in the consulting space, whereas I was talking about responsibilities in here. But I think in general, it's one thing that's really fascinating if you're dealing with teams in an organization is to try to rotate people from team to team periodically so they start to see other parts of the system. And a story I heard from Google a long time ago that was kind of fascinating, and they said they kind of record everything about what happens in their development organization. And they found quite often that basically for certain parts of code, they would deteriorate over time and nobody on the team realized that it was deteriorating. And the reason why is because there was a bit of siloing, and they kind of discovered that it's like, this looks normal to me. And you kind of see in your mind, where things are, and the code starts to drift away from that because, it's like you've got a good mental model of where things are, right? Sometimes a great way of going and approaching that problem is to go and bring new people onto the team. Because when you bring new people on the team, they're seeing with fresh eyes, and hopefully they're honest, and they go and they say, this makes no sense at all to me, right? And you want to tune for the fresh eyes, as much as possible in an organization. So it helps to go and have an outside view. I think in general for consulting, it's kind of like, there's a lot you can do with long-term consulting, but having fresh eyes periodically is useful. And fresh eyes deteriorate a little bit over time. It's just, that pickle metaphor, so. Yeah.
Okay, thank you.